Remember that sunlight hits Earth and it's either radiated, reflected, or absorbed. Earth radiates heat, and that heat is trapped, some of that heat is trapped by the greenhouse effect, and that's a good thing. It keeps the planet warm. It's mostly carbon dioxide gas that does the job of trapping heat. There are other molecules, and we'll look at a lot of those molecules and how they trap heat. It's important to understand, though, that it's the carbon dioxide leads to warming because these molecules that are gases in the atmosphere keep the heat from escaping out, and we have more than the regular amount, more than 80% of the heat's been trapped, and so that's leading to warming. We're a long way off from the out of control, way too hot, 96% carbon dioxide atmosphere of Venus, but we do face some difficult changes due to the enhanced greenhouse effect and global warming. So we're going to focus on the chemistry of greenhouse gases. These molecules have shapes and they're based on Lewis structure.
So this is the process of drawing Lewis structures, for which one thing you will definitely need in front of you, so get it out right now, is the periodic table. And you're going to be using that periodic table to look at the family numbers when you're given a molecule. Here's the molecule's chemical formula. For example, this is the chemical name methane, which is the chemical formula CH4. It's the first in the family of alkanes. It's a hydrocarbon where you can calculate the number of hydrogens based on the number of carbons, and meth means that there's one carbon. So that's CH4, that's the chemical formula, and use the family number for each atom. So carbon is in family 4A, so that would mean that it has 4 valence electrons, and hydrogen is in family 1A, which means that each hydrogen, and there's 4 of them, each hydrogen has 1 valence electron, times 4 is 4 valence electrons from those 4 hydrogens. Adding them all up, that's the contributions from all those atoms. It would be the 4 from the carbon plus 4 from the hydrogen. There are a total of 8 valence electrons. So then you want to take one atom and make it in the middle. That's called the central atom. And so the best choice here is the carbon, because carbon is something that can form more than one bond. Hydrogen will never ever be in the middle because it can only form one bond. So carbon is the best choice. Another reason why carbon is the best choice is because it will give you a symmetrical molecule. It'll have one carbon in the middle and 4 hydrogens all around it, as opposed to if you chose a hydrogen in the middle, then this would not be symmetrical, and nature likes symmetry. So connecting the outer atoms to a central atom is with individual bonds, so single bonds, and each bond represents 2 shared electrons. These are covalent bonds, remember. So then you're arranging all of these so that every single atom has its octet rule fulfilled. That's 8 valence electrons, except for hydrogen, which has the duet rule that needs 2 electrons. And these are all electrons that are shared between those atoms. These are examples of Lewis structures. This is what you end up with. These are 2-dimensional representations. So these are flat, and they are the atoms. They show the atoms and how they're bonded. So they're called Lewis structures. They're also called structural formulas. Again, using the word formula like chemical formula, it's not a math formula. It is the atoms and how they're bonded, a structural formula. So this is showing a molecule that has what's called resonance. This is ozone, so that's O3. And when you see this double-headed arrow, it means that both of those Lewis structures are equivalent. They're both possible. They're both correct Lewis structures, and that this molecule switches between this version and this version. The only difference being is the position of this double bond. So here the double bond's on the left, single bond on the right, and in this ozone the double bond's on the right and the single bond's on the left. So this is equivalent Lewis structures. It's called resonance, and we'll be getting into the details of drawing not only the Lewis structures but also those resonance structures. Now let's work on this worksheet, drawing Lewis structures.